Hi, welcome to the Shuko Math Lab differential equation problem solving session. So here is the problem we're going to solve today. It's y squared minus 2xy dx plus x squared dy equal to 0. And the initial condition is y1 equal to 2. Okay, so let's take a look at these problems and let's decide which methods, we can use. And so for this problem here, I think I will try to rearrange the terms and to see what be I can change to the like a Bernoulli equation. And some student asked me, say, why, how did you spot you can change it to Bernoulli equation or not? I think my kind of the tricks here is I look at all the y terms, like this is the y terms, this is the y term, and this is the y term. To me, like this dy term related to x squared, and this y term only related to the x, this y term only related to the dx. So I think, if you have all the y terms, they are kind of linear, and then in this situation, I think the Bernoulli equation will be a good way to approach. So here, that is at least is the trick I typically use to see whether I want to rearrange the terms and change it to the Bernoulli equations here. All right, so let's go ahead and start it. Just like I said, the first things I always like to put the dy dx together, so I can divide it by dx. So I have an x squared. All right, and then the dy dx, I just move the term to the front, then plus y squared minus 2xy, okay, equal to 0 here, okay. And then I will divide out the dx squared, here, right? So I divide the x squared out. So I will have the dy dx is equal to y squared over plus, I'm sorry. So here, need to be very careful. One thing I found out for doing the differential equation is sometimes those silly algebra mistakes is really going to kind of screw you up. And so just like a simple plus or minus sign. So be very careful about your algebra. So y squared over x squared, then minus, this is the 2xy, x squared equal to 0. So I will have a dy dx, and then this is the plus y squared over x squared. And then here I have minus 2xy equal to 0. Just try to, remind what is our Bernoulli equations looks like is something like this. Dy dx plus px y equal to qx y to the n. So I will rearrange these things a little bit to match my Bernoulli equation standard form. So I will see here, so the dy dx plus, so it's minus 2xy equal to the negative y squared x squared here. All right. So now this one's here. So negative 2x. This is my px here, right? And this is y squared. So this is my n. All right. So after this, then we can start the methodology we use. How do we do the Bernoulli? So this match the Bernoulli equation. So the step number 1, we said we define the function v is equal to y to the 1 minus n. So y equal to 1 minus 2 is y to the negative 1 is y over y. All right, now we say we take the derivative of both sides. So the dv dx is equal to the negative y to the negative 2 dy dx. That's right. Okay, good. Then now the next thing here is change to the dy to rearrange this equation to the dy equal to, so the dv dx. So I can do what? I can multiply both sides by the negative y squares here, correct? All right, so here, so let's go ahead, try to do that. Okay, so here, let's go back here. So times negative y squared. So I will have a negative y squared dv dx is equal to negative y squared is simple. So this is dy dx. All right. So this is dy dx. All right, so now let me highlight the equation. I need to substitute 2, replace 2. So here, okay, I find my dy dx. As we did many this Bernoulli problem, as you can see, the steps always are almost the same, exactly the same step 1, step 2, step 3. After I find the dy dx, I substitute to this yellow one I highlight. So it's a negative y squared dv dx minus 2 of x to the y and equal to negative 1 over x squared to the y squared here. Okay, so do we still remember what is the next step here? Yes, we want to get rid of whatever the constants in front of the dv dx to make sure this is the change to a first order ordinary differential equation. So what do we need to do here? So we will say we will divide by negative y squared divided by negative y squared. Okay, so let's divide by negative y squared and see what happens here. So this 4. So this one negative cancel. So it's dv dx. Then the negative cancel plus, right? 2x and y over y squared. So you have 1 over y here. Okay, and then here, so now this one's here, the negative cancel, so y squared, so it's 1 over x squared. Good. All right. So after that, this next step is to find what? Finding the integration factors, right? So it's a very important step, integration factor. Okay. So and this is the equation I want to highlight, right? Because this is the equation later I need to multiply my integration factors here. All right, so now my integration factors here is du dx is equal to this term, right? My pt terms here. So this is my new pt terms. So this one's here will be 2x times u. Then I want to solve for what? Solve for u. So this one we can use the separation. So du over u is equal to 2x dx. Okay, so then we integrate. I can get the natural log u is equal to natural log x, the 2. The 2 you can move to the inside with the x squared. So I will get my integration factor is u equal to the x squared here. All right. So remember which one we multiply these ones here. So we multiply the integration factor to this equations, right? So we will have x squared dv dx plus 2 times x, so it's be 2x 1 over y and equal to 1. And now in here also, let me highlight this ones here. So for these numbers here, we know the v equal to the 1 over y's, right? Okay, so now here I have 1 over y. So what I can do, I can change this to the x squared dv dx plus 2xv equal to what? Equal to 1. So remember the integration factor, then make these terms here become the what? Become the derivative of these two values, so it will be x squared v's, right? So then you're applying the product rule, you will get here. So it's x squared v is equal to 1. Okay, great. Doing just great. And now number 7, what here? Integrate both sides, right? Okay, so integrate both sides. So I will have x squared v, because if you integrate like this, right? So then by the fundamental theory of calculus, you take derivative, integrate, just be the self. Then the 1 you integrate, it will be what? Will be the x plus c, right? Okay, great. And then we can substitute the v is x squared over y equal to x plus c. All right, so substitute the initial value. My initial value is y1 equal to 2. Okay, so then let's see here. So 1 to the square over 2 is equal to 1 plus c. All right, so equal to 1 plus c. So what I have here, so it's 1/2 plus 1/2 equal. So I'll have 1/2 equal 1 plus c. So c is equal to the negative 1/2. Finally I got my answers, right? So this is x squared y is equal to x minus 1/2. Okay, now I can times the here I can flip it, I guess. So then the y over x squared going to be equal to the 1, the x minus 1/2, then times x squared. So I will get y is equal to the x squared, x minus 1/2. All right, that will be our answer. So it's quite simple. As long as you can spot it to try to say, hey, I think I can use the Bernoulli equation. Remember I said the key things I look for is all these y terms to see are they all kind of by itself, and then maybe I can just manipulate the equation to change it to the Bernoulli equation form. All right, I hope this problem can help you to do your homework, and let's take a look at what the problem is going to work tomorrow. All right, have a good day, and talk to you later. Okay, bye-bye.